Okay, today's lesson is about using graphics in XNA. Unusually, I'm not going to start off by teaching you the XNA code that you can do to directly draw graphics on the screen. Instead, what I've done is, in the project that you've downloaded and we're viewing on the screen at the minute, I've included a class called Abstract Sprite. What this provides you with is all the basic functionality that you need for you to actually draw something on the screen without having to write too much XNA code. I will do a separate tutorial about the idiosyncrasies of actually using XNA code directly, but what I wanted to show you is a modular way of working so that you're able to incorporate graphics and reuse what you're doing. So the Abstract Sprite class, what it does is it allows us to incorporate either a single frame of animation, as in a static image, or an image with multiple frames of animation in it, and animate it if we want to. So to do that, what we've got already in our content is saucer.png, which is a PNG file with multiple frames of animation. Okay, it's a very basic flying saucer. It came from the internet. I'll include a link to where I got the graphics from because I believe that it's appropriate to cite who created them in the first place. Single saucer.png is purely just one frame of animation, a single graphic. How I got those in there in the first place was by right clicking on XNA game content, doing add existing item, and by browsing to wherever my graphic was, for example, it could be I'm Batman, click add and that will incorporate it into there. So once we've got these images in here, that means at that point we can use them. Now in order to do that we need to know their asset name. So if I just scroll up a little bit, because I believe my picture will be in the way. If I click on saucer.ping, you'll see that it's got an asset name of saucer. So this is the same as when we were working with sprite fonts. Right. To get things to work, we have to do three basic things to get the thing on the screen. The first is we need to create a variable to hold our abstract sprite object. We need to populate that variable with an abstract sprite object, and finally we need to add that object to the game components, which will allow it to be drawn on the screen automatically. This is a much simpler and much easier way of dealing with things than writing it all in your main game code. If you do that, you're going to be struggling very quickly when you write your program to understand what's going on, because your code will become too complicated and difficult to read. So let's look at the process. First things first, create a variable that's going to hold your abstract sprite object. So put the right data type first, abstract sprite. We'll call it static. Sprite. Okay, so that's created the variable. The next thing is we need to, in our constructor, populate that variable. So static sprite equals new, because we're creating a new object, abstract sprite, because that's what type it is. Okay, and the parameters for a single frame of animation image is first of all this, so that you link it to this game, and secondly a string that specifies the asset name, which is single underscore saucer. Okay, note it's not single saucer.png, it's not the file name, it's the asset name. Okay, at that point what we've done is that will now at this point load the graphic, it will create the object, and it will all be held in static sprite. The next thing we need to do is, in our initialize method, is to add that to the game components. Right, so the game components is a list of things we want to be accessed and drawn every screen update, every time the screen's refreshed. So in this case, it's static sprite that we're adding. Okay, so at that point what we've done is we've added the sprite. If we were to run the program now, it would appear on the screen and it would be drawn every screen update. The only thing is, it would be in the top left hand corner, which might not be the best place for us to start with it. So let's put it somewhere where we can actually see the thing. So if we just go to static sprite, it has a property called position. Okay, and that position has an X and a Y value. It happens actually to be a vector 2 data type, so you could assign position all in one go if you wanted to. So I'll put it 100 and the X, so that's 100 across, and then we'll put it 100 in the Y, which will be 100 down from the top of the window. Okay, and at that point that should now be drawn on the screen when we run the program. Okay, and there's our flying saucer. Not particularly exciting, I know, but we have to start somewhere. So that's a very quick way to get yourself with an image into your game. And you can keep adding as many of these as you like, and you know, to be honest, XNA is quite robust. You can get a good couple of hundred on there if you really wanted to. Although, you know, the bigger the image is, the more load there is on it. So the next thing to do is to say, well, that's fine, but what about if we wanted an animated one? In actual fact, it's no more difficult than we've already done. We need to add one little extra bit of code to the update method, but apart from that, it's quite simple. So what we'll do is duplicate the static sprite for a start. So create a new class variable. Anim sprite. And then in our constructor, we will populate anim sprite. Now, there's an additional parameter when you've got an animated image, which is to specify how many frames there are. I have commented the code. So the documentation will explain to you on there what exactly you're expected to do. At that point we've loaded that one in. The only other things we need to do at this point is to then replicate what we've just done with the static one in the initialize method. Okay, and swap static sprite for anim sprite. Okay, and obviously, sensibly, we need to move it somewhere other than the first one, or else they'll just overlap each other. We'll talk about what happens when they overlap in a minute. Okay, at this point, we can run the program, and we'll see two sprites. What we won't see is any animation. To make use of animation, so to animate the second sprite that we have there, we need to actually, in the update method, tell that sprite to move on to the next frame of animation. So bearing in mind that we called our animated sprite anim sprite, what we do is inside our update method we can put in anim sprite dot next frame. Okay, what that tells it to do is it tells it to animate in a loop round the frames. Okay, so every time the screen updates, the frame updates. So clicking play now, we'll see that we've got a nice animated sprite there. Not the best sprite in the world, but it does actually demonstrate what we want. Right, there is one other feature that I will show you in a minute that's quite handy with this abstract sprite that allows you to debug your programs a little bit easier. But we'll come back to that in a minute. The first thing I want to show you is what happens if the images overlap, because that's quite important, because you need to understand how the process works. So the first thing I'm going to do is I'm going to make them overlap horizontally and vertically So if we put them at 120 and 120, this animated one, and then run the program again, can you see that the second sprite that we added is above the sprite we added in the first place? Okay, that's fairly important to understand because that can affect how you add things in the initialize method. So first thing that appears is the thing furthest back on the screen. The last thing that's on this list of initialized elements will be the thing nearest the front. There are other little tricks and tips you can do to change that, but maybe we'll leave that one for another lesson. Okay, one other handy little thing that I have with this, and I will just move it down the screen a little bit more before I show you, is that I've incorporated a little bit of extra code, but it requires us to use something that you've never encountered before in XNA or Visual Studio in any of your lessons. When you go to the project menu, at the bottom there is XNA game properties. If you click on there, it opens up another window that you may or may not have viewed before. And if you look down here, one of the things that you have is build. Now in build, if I add in text to my compilation symbols, inside my code that will now give you, when you run the program, a little bit of information about your sprites. So that's quite useful. It also updates you in terms of what size the screen is, and it's brilliant for debugging. You'll notice it gives you the coordinates, but it also gives you what's called a collision rectangle, which we will talk about when we talk about collision detection. So that's really quite useful, and one of the things that most students are asking me for nearly every year, so I thought I'd add that in for you. Right, very briefly, because I've only got a couple more minutes for this, because I don't want more than 15 minutes for my lesson. We'll just have a quick look at abstractsprite.cs. Okay, there's lots of code in there that you could have a look at, but more importantly are the public variables. Everything that you see on here are things that you could modify. I wouldn't recommend you modify datum origin because it's automatically calculated for you, but you can, for example, modify the angle of your image, which isn't particularly useful for a flying saucer because it's round. You can also modify its scale, which I don't recommend you do, but it is possible to decrease the size of the image. And that's a value between 0 and 1, 1 being 100% as in normal size. You can also alter its tint, so you can affect the colour of it. You can set its position, and you can set its direction of movement. So we will look at that when we talk about moving our sprites around, but we'll leave it for today. Rough collision is for when we want to do collision detection, and also just as a facility within your sprite, it's useful to know the screen limits in case you want to do anything else with it. Alright, all of these are accessible simply by typing in the name of your object, dot, and then it will list all of them there. Okay, so if we were to go for tint, because that's quite a good one to demonstrate it with, what we can now do is we can do equals, and then using the colour class, we can say we're going to tint it red. Okay, so that will tint what we've just done. So that's quite useful if you want to go through and maybe affect how your ship appears, depending on how well it's working, or you want to have different coloured players. It's all quite simple to do just by using tint. Right, that's it for this lesson. What I would advise you to do is to try and create first of all a background, and then maybe get 1 or 2 sprites to appear above that background, and then we will look at the next lesson as to how to move them around.